Hello and welcome to Data Engineering Explorers, and today we're going to explore the differences between table format and file format. Okay, let's give some names, and maybe it's clear for you already, but I'm gonna go through the concepts either way. We have here some table formats. We have nowadays Data Lake, Iceberg, Apache Iceberg, and Apache Hudi. These are all table formats, and we have file formats. We have JSON, CSV, Avro, ORC, Parquet, and all of them that have different structures, such as CSV, it's comma divided, and it's quite near Excel files, sheet files. You have Parquet that is column oriented, and you have Avro that's row oriented. So you have a bunch of files that are different, and we have the table format that have each its specifications, but them all have ACID compliant. They all are ACID compliant. And this is actually the structure of a table format. Actually, this is a structure of a Data Lake table format, sorry. And it is consistent of, you have a concept of a table, you have a folder here that is a table, and you have its metadata and its data. So that's the main thing between storing your data as a file format and as a table format. The table format has a big emphasis on metadata. So for each, for instance, ACID compliant transaction, you have a file. For each insert, for each whatever, you have all of the transactions executed on the data, and you have the data actually here. You don't have it exactly like this. Maybe depending on the table format framework, you have different kind of partitioning, and yeah, but this is only an example. And you have, so the table format consists of a table, metadata, and its data. And you have here the main difference between a table format and a file format. If it wasn't very clear yet, I hope this makes it clearer. The table format has it all, right? All of this consists of the table format, the metadata and the data, and the file format is each one of these files. So you have here two kinds of file formats. You have a JSON and you have a Parquet, but each one of them are a file format. And you have differences in storing the data between when you use table format and file format. So here you have the table as I have the table format as I have already gone through, but you have the metadata and the data, and you store it on different partitions and etc. But here actually we have this file format. It is example. It's actually compliant to the Hive table format, I believe, but the Hive table. You have here for each partition you have some files, and for example, let's say you have a column data, and if the value is 1, you have all of the files that the column data equals 1 is here. So to make that more clear, for instance, if you have yesterday's data, it will all be here, and today's data will all be in the same partition. So why is that not good too, right? Because when you select data from your table, when it has a Hive format, in this case, you have to, and you have where x equals 1. And in this case, we have the partition as data. So the partition not being x, you have to go through all of the partitions to find all of the data that have x equals 1. So let's say in here we have a row that has in here 2, and here 2, and here 2. So you have to retrieve data from all of these files. And this is a pretty small example. Imagine if you have a database of data stored about your users, and you have, let's say, I don't know, 1,000 users, and you want to get a specific location user. So if you want all of the users that are in the US, you have to go through all of the 1,000 users to see what location they are, because if the table isn't partitioned in the location column, which is probably not. So you have this problem, right? And when you have a table format, you have the framework of it that has access to all of it has files, and it has engines that already do that for you and make queries optimized. So you don't have to go through all of this manually, because the framework probably does something like that. But when you're doing this, when you define a table by yourself, you have to do this. You have to go through all of the data, and you have to optimize that query afterwards. When you're using a framework, you don't have to care about that. You don't have to not care, but you don't have to worry about that. So you only query the table as you would query a table in a warehouse, and that's it. The framework takes care of the optimization of the query and looking into its partitions. So, iterating that again. Instead of manually configuring the querying and the storing, so if you store the data like this, you have to define the column, see which column makes more sense. You have to define it, you have to make code for storing it in a certain way. And upserting data, that's a big thing on this. You have to, when you have to update data, you have to go through all of these too. So instead of going through all of this, you have only the framework having the new transaction here and updating the metadata that is here. So if this is getting quite confusing, please let me know and I'll make another video on that. But this has this checkpoint. This file has all of the files that are actually in this time. At this time, you have all of that data. So for instance, if I did a bunch of different transactions here, I updated some rows, and I actually don't use these two files anymore. So I have the files of my checkpoint would have let's say we don't have file 1 and 2, so we have 3 to 10, and this would be on our checkpoint saying, oh, as you have updated your data, you have inserted data on other files, and now your data in its current state, after all of these transactions, you only have your data consists of the files 3 to 10. So that's quite complex to do it manually. And that's why it's interesting to leverage table formats. Instead of manually configuring all of the use cases, as I just said 2 of the use cases, inserting data and querying it, but you have other use cases that you have to take into consideration. So instead of doing that manually, you should consider it at least using a framework and leveraging its features. So some of its features are the clear definition of a table, because sometimes that's quite hard. When you have a data lake, you don't have a clear definition of what is a table. It allows time travel, right? Because you have the data stored when it was in its first iteration, and you have each of the ACID transactions that was executed, and you have each of the checkpoints that it had. So you can go back and say, oh, I want to compare the data from our users, how many users we have, whatever, and from the first quarter of the year, and the last quarter, and you are able to do that because you have time traveling here. And when you look at this format, it's quite complex, but when you look into the command itself, you only have to pass some parameters to use time travel. So this seems more complex than it is actually. So yeah, that's it. File formats are simple and they are necessary, but table formats are much more sophisticated. They allow ACID compliant transactions, and yeah, I would suggest you highly to look into that. So if you're interested, here in the channel we have a project, an ongoing project. I'm gonna link the playlist down below, but we're going to develop a high value platform, data platform in iterations, so you deliver value quite quickly and also improve on best practices. So if you're interested, please give it a look. And if this video was helpful in any way, please give it a like, subscribe, and leave a comment if you want to. Until next time.